Welcome to the Simply Savant Online Learning Center. Today we will be going over some basics of chemistry. Okay, so our objective today is to familiarize you guys with the periodic table of elements and how chemistry works with atoms and molecules and how they bond and stuff like that. So the table of chemical elements that was proposed by Dmitry I. Mendeleev. This is actually what everyone knows as the periodic table of elements. So here is the big cheese. You have the periodic table of elements. It's actually split into different groups. The columns are called families, and the first column is called the alkali metals, as indicated here. This main section is called the transition metals. This family here is called the halogens, and the last family here is called the noble gases. Okay, and it's actually called the noble gases here because they are inert, meaning they're very stable. They're awesome that way, and they don't like to share their electrons with anyone else. And we are very, concerned about why alkali metals and halogens are special, column 1 and 7 over here, because here they have 1 extra electrons that they don't need, and here they have 7 extra electrons. And in chemistry, usually when we deal with electrons, the magic number is 8. So this is actually more like 9, and this is 7. So, somehow they might share an electron or one donate to the other partner to form, exact bonds. But I'll go over it into those details later. So this is the periodic table proposed by Dmitry Mendeleev. Alright, now we have elements. Identifying atomic symbol, mass, and number. Okay, so the number on top of the element symbol is the atomic number. The atomic number indicates how many protons the element has. A lot of people think elements are ordered by atomic mass. That's actually not true. It's ordered by atomic number because every single element has a different number of protons. And what are protons? I'll go into that a bit later in the lesson. The atomic symbol right here is actually an abbreviation of its Latin name. Some we might be familiar with, like carbons, C, heliums, He, and hydrogens, H, and nitrogens, but not all elements' Latin names are the same in English. For example, gold is actually Au, and silver is actually Ag. Now let's move on. So what is chemistry? Well, you can say it's the study of chemicals. I like to think of it as the study of change. Okay, it is the study of change in matter. How matter interacts with each other, and through those interactions, how matter changes. And first of all, chemistry is concerned with the atom. The atom is the basic unit of matter. All matter is made out of atoms. Individual little particles that cannot be separated further. Okay, so that cannot be broken down further. Now, when elements, now when you're talking about elements, you're talking about different kinds of atoms. Elements are actually classifications of atoms based on not their mass, not their number of electrons or neutrons, but based on their different number of protons. So an element here is, very similar to atom, a pure chemical substance that cannot be broken down into simpler substances by chemical or physical means. So very simple, element is, like the atom, the basic unit of matter. Okay, all atoms have, belong to an element. Hofbrinkel, or here it says Brinkelhof, is an acronym for the 7 diatomic elements. What are diatomic elements? These elements are unique because when, let's say, you find, something like gold or silver, they're just elemental in nature, meaning they're single atoms bonded together. There's nothing unique in the sense like the Hofbrinkels. They actually form bonds with each other. They are called diatomic elements, meaning that in nature you always find them bonded to something else. I'm sure maybe in TV or at the hospital or maybe even at the racing track you see O2 a lot. That's because oxygen is diatomic. When we find fluorine, oxygen, hydrogen, chlorine, nitrogen, iodine, and bromine, these are actually all diatomic elements, meaning that in nature it's like Br2, I2, N2, Cl2, H2, O2, F2. You're not going to find them alone in nature because alone they are very unstable, and when they find one more element that's the same, something happens between them. They form what's called a covalent bond, and they form diatomic elements. These are usually very, very stable within the atmosphere. Fluorine by itself can be very poisonous because it's very unstable. Well, that's luckily, we have F2, which forms a much, much more stable molecule. Now, let's talk about what are molecules. Molecules are groups of at least two atoms held together by chemical covalent bonds. I'll go into the difference between covalent bonds and ionic bonds a little later. Okay, so example, you breathe out CO2, you breathe in O2, you drink H2O. These are all examples of molecules. Okay. Next, you have compounds. Compounds are formed by ionic bonds. Okay, a combination of two or more elements. And here we have like table salt called sodium chloride. And next, we're going to go over what is in the atom and what it is. Okay, the atom is actually consisting of three different particles. They're called subatomic particles, and the first one is the proton. The proton, indicated by the plus charge here, is located in the nucleus. Okay, it has a positive charge. The nucleus is what's inside the atom, much like we taught you guys throughout the biology lesson. And the electron is actually located on the outer shell and outer electron clouds of the cell. The electrons are marked with a negative charge. Neutrons add mass to the atom, but they don't affect it in terms of charge. And a stable atom is usually an atom that is very balanced between positive and negative charge. For example, here we have the helium atom. The helium atom has 2 electrons and 2 protons. And this is a much more vibrant and colorful illustration of the atom. Here you see the blue particles are the protons. These are the neutrons, the orange ones here, and all these colorful electrons floating out in these rings or electron clouds would be called electrons. Because electrons are very, very small, their mass is pretty much negligible when it's compared to protons and neutrons, which have very similar masses. That's why that's one of the reasons they're able to float around very, very freely around the nucleus. Now, imagine your fist is the nucleus, and you are standing inside the Staples Center or any other football stadium or any other soccer stadium or hockey rink or whatever like that. Okay, now the entire rink or the stadium would be considered the electron cloud. So that's how big the nucleus is compared with the electron clouds and the paths that these electrons circle in. Okay, now let's move on. Chemical bonds. First, I'll go over ionic bonds. Ionic bonds are types of chemical bonds formed through electrostatic attraction between two oppositely charged ions. For example, sodium chloride. For example, sodium has one extra electron than it needs. Okay, and chlorine just needs that one extra electron. So what happens is sodium actually wants to donate one electron to chlorine. And then now they have 8 on the outer shell. They're both happy. You have 9 minus 1 equals 8, and 7 plus 1 equals 8. So that's actually what happens when you form ionic bonds. One partner donates electrons to the other partner, and both of them are happy because remember we talked about the magical number 8? It forms a very stable compound. For covalent bonds, this gets a little more interesting in chemistry topics such as organic chemistry, non-organic chemistry, or atmospheric chemistry. You're mostly going to deal with covalent bonds. Okay, this form of bond is characterized by sharing of pairs of electrons between atoms and other covalent bonds. For example, you have diatomic molecules such as hydrogen, and before we went over, such as water, oxygen, carbon dioxide, carbon monoxide, your general anesthesia that you breathe in through surgery, desflurane. Those are all covalent bonds. And covalent bonds have two kinds. There are nonpolar covalent bonds, which are characterized by sharing electrons equally, and polar covalent bonds, which are characterized by unequal sharing of the electrons. What happens in polar covalent bonds is usually one atom is very negative or very big compared to the other atoms. So that's why it attracts the electrons more, creating an unequal sharing of electrons. Now we'll go over intermolecular attraction. Well, we went over bonding between atoms. When we have molecules, there's actually attractions between. Okay, first we have dipole-dipole attraction. This attraction actually applies to every single molecule out there. Just like how all mass is affected by gravity, all molecules are affected by the dipole-dipole attraction. Now, for London dispersion forces, this is the type of force that acts between atoms and molecules. This is the weakest type of intermolecular force. In hydrogen bonds, what happens is that when you have hydrogen, such as in water, when it's close to other molecules with very, very, very electronegative atoms, such as oxygen or fluorine, it forms a hydrogen attraction. So that hydrogen forms an attraction with that electronegative atom, and it forms a hydrogen bond. Sometimes in covalent bonds you have double and triple bonds, because while you can share one pair of electrons, why can't you share two or three? Sometimes sharing two or three pairs of electrons actually make the molecule a lot more stabler. For example, this is an illustration of two molecules sharing only one pair of electrons, as you can see here. And this is another illustration sharing two pairs of electrons. As you can see, the general rule of thumb in chemistry is that the more bonds two atoms share together, the closer and tighter it becomes, which makes more sense. Because when you're having only one attraction, it's not as tight. But when you have two attractions, the attraction is a lot more stronger, and the two atoms are a lot less likely to break away. So you can see here, the two nuclei here are much more closer together than the two nuclei here. And this wraps up today's lesson on the very basics of chemistry. Thanks for listening, guys. This is Rick, and you are watching the Simply Savant Online Learning Center.